Hey kids, Mr. Murray here, Mr. Murray's Mathland, and just doing a second example of evaluating a definite integral, this time with a trig function. And here is the graph again to visually support our findings. The function sine of theta over 2, here you can see that, it's got that period of 4 pi. And we're evaluating the definite integral from negative 2 pi over 3 to 2 pi. So that would be about here. Here's about negative 2/3 of pi, all the way to positive 2 pi. So I would say if you have an understanding of your definite integrals and what they give you, that this should be a negative area, this should be a positive area, but there's more positive than negative. Our final answer to this should be a positive quantity. So without further ado, let's find out what that is. So first things first, remember we integrate sine of theta over 2. And so the antiderivative of sine is negative cosine. So we've got negative cosine of theta over 2. But remember with that on the inside being, theta over 2, there's a little chain rule that would need to be accounted for. So I'm going to divide by 1/2, in other words, multiply by 2, right? And therefore, if I were to take this derivative, negative 2 cosine, I would get positive 2 sine of theta over 2. And then when I multiplied by 1/2, it would cancel out the 2 and leave me with that. So there is our antiderivative. And now we are evaluating from negative 2 pi over 3 to 2 pi. So we plug in that upper limit first. So negative 2 cosine of 2 pi over 2, which is going to reduce to pi, minus the difference between plugging in that bottom one. So watch this double negative here. Minus negative 2 cosine of 2 pi over 3 divided by 2. 2 pi over 3 divided by 2 is just going to give you negative pi over 3. Yeah, I don't know if I said negative, but certainly when you plug this into there, negative 2 pi over 3, you divide it by 2, will become negative pi over 3. And so now it's just a lot of trig, going back to your old unit circle days. So let's simplify, let's evaluate. So this 2 over 2 on the inside, that's just pi. So negative 2 times cosine of pi is negative 1. Minus, well, actually, maybe I'll just take this minus a negative and make that one big plus there. Just made that plus 2, and the cosine of negative pi over 3. Cosine of pi over 3 is 1/2, and negative pi over 3 is in quadrant 4, where cosine is still positive, so it's positive 1/2. And so here we go. We simplify and we get positive 2 plus 2 times 1/2 is 1. And our final answer is 3. 3 on the dot. Seems a little strange that that would be, you'd get an exact kind of answer like that and not anything with decimals or pi in it. But, negative 2 pi over 3, like we said, that's about there. And all the way to 2 pi, giving us this positive area. And you see that far outweighs that our cumulative total is a positive 3. But just to see this again, we will check it with the graphing calculator. Great to know these features. So I put it in Y1. Here's my graph. So I know I put it in correctly. It's got the same windows as on paper. Second trace, that's where we find this on the graphing screen, the menu here. Item 7 is our integral. And we're going from negative 2 pi, and you can type it right in, negative 2 pi over 3. Enter. Your upper limit is positive 2 pi, so 2 pi. I'm not sure why that was not valid. Maybe it's right at the edge of my window. Maybe I'm supposed to go a little bit further here. This is good troubleshooting. This is happening on the spot here. Sometimes things happen. Let's see, I just changed my window to go slightly beyond that 2 pi. Maybe it has to really fit perfectly in there and it can't be an endpoint. So I'll do this again. Second trace, 7 from negative 2 pi over 3 all the way to 2 pi. And you see it worked. Then maybe that was it. I'd never seen that happen before in 20 years of teaching, but there's the answer. Now what did it give us? It gave us 3. It gave us 3 on the dot. Very nice. So we know we did that right. Or again, that whole troubleshooting with the Windows thing, sometimes that's a little annoying, and that's all the more reason why you might like to do it on the home screen often. So again, where is that? Math 9, function integrate, math 9. And again, we're going from negative to, just to make sure, you should be in radian mode for all these. Calculus, you're always in radian mode. And especially since we're doing a trig function here, that's when that's necessary. And you can either type sine of x over 2, type it directly in. You could do the shortcut and use y1. Always with x, though, when you type on the home screen, and with respect to the variable x. And so we should get the same 3. Look at that. Very nice. Okay, so great confirmation of our graphic results, and another example of how to use the calculator and how to do it by hand, and brush up on your unit circle since you guys love pre-calc so much. So if you got any questions, hit me up. Otherwise, hang in there and keep doing the great job you're doing.